We're going to continue talking about verifying identities today, so doing these kind of mini proofs, working from one side of an equation or the other. And the reason I want to do a few more examples is just to show you a couple more techniques and to remind you of a couple things. Then at the end of the lesson, we are going to show you how to tackle some of this on the calculator. All right, if I wanted to verify the trig identity on part A, I would choose to work with the left-hand side because the right-hand side is most definitely the simplified version, right? There's a lot more happening on the left than on the right. Now, the reason I picked this example is because I wanted to remind you that even though we've predominantly been using the Pythagorean identity and then just algebra skills, factoring, combining like terms, multiplying, we also have those other identities that are still at our disposal. So our even odd identity and this one, the co-function identity. So don't forget that those you can use those as well. Remember, there's a PDF file of that complete list if you ever want to have it around as a point of reference. The co-function identities are the ones dealing with complements, so things that add up to 90 degrees or pi over 2. And you will find, if you don't recall, that secant squared, its kind of complement is cosecant. Well, I should say secant and cosecant are complementary, and so if one is squared, the other would also then be squared. So this can become cosecant squared of just x, and then I can bring down the 1 from above, and now that is a Pythagorean identity for cotangent squared of x. So just remembering those other identities can help you get to a solution quickly. Moving on to letter B. This is one where you could perhaps work with either side and get to the solution. Because I want to show you or remind you of a technique, I'm going to choose to work with the left-hand side. The reason that I would probably even choose this, even if I weren't trying to make this point, is because when I see that, I automatically think conjugate. Remember when we worked with getting the trig out of a denominator, and therefore we multiply by the conjugate? We did that in, I think, our second simplifying lesson. That means I would think, oh, I want to multiply this by a conjugate, because I know when I do that, I'm going to get rid of the denominator. And isn't that what we want to happen? We have something with the denominator on the left. We want to get rid of the denominator when we move and get the answer on the right. In case you've forgotten how that happens, well, first of all, let me maybe distribute the numerator. And I will go ahead and FOIL out the denominator. We'll have a negative sign squared and a positive sign. No, I said that wrong. We'll have a positive sign of theta and a negative sign of theta in the middle that will cancel. And a 1 minus sine squared theta on that outside. So here in the bottom, 1 minus sine squared theta is a Pythagorean identity. Oh, so I don't think I really wanted to cancel or multiply that out. Let me leave the cosine out front. I don't know if you know why I'm thinking that yet. Sometimes it's helpful to multiply it and sometimes it's not. But the reason I'm thinking not is because then that cosine can cancel with the bottom. And sometimes that happens. Sometimes you do something and you have to undo it. That's okay. That's the beauty of math. We can do that. All right, so I'm just writing maybe an extra step for emphasis here. 1 plus sine x all over cosine x. So you can see if I'm comparing it to what's at top, that's what you always want to be doing. Okay, where am I and where do I need to be? I see I have the addition I have two parts in a numerator, but the problem is I have the denominator. Now, if you just have one denominator as opposed to two denominators, you can divide that out. And by that I mean you can write that as 1 over cosine x plus sine of x over cosine x, which gets us what we want, right? 1 over cosine is secant, and sine over cosine is tangent. I didn't quite leave myself enough room there, did I? All right, so I eventually made it to the left-hand side. Because of space, I'm not going to work through the other side like I did the other day, but I imagine that you could get there by changing secant to 1 over cosine and tangent to sine over cosine and working and getting towards a common denominator, right? I think you might have to use the conjugate though again, still on that one, but I'll leave that for you to discover if you want to. All right, letter C. Doesn't that look like a strange mess? I remember seeing a problem like that and being intimidated by it. So if you're feeling that, I understand. All right. Well, the good news is I see conjugate again. I could see a conjugate. So for right now, even though the rest of it looks intimidating, I'm just going to go with conjugate because that's what I see. And I need to erase this stuff because I know I'm going to get strapped for space. All right. I'm just going to do conjugate because we've been talking about it and it looks like it could be helpful again. So if I want to multiply by the conjugate, if I'm wanting to simplify that denominator, I'll be multiplying by 1 minus cosine theta. Take the opposite side of the denominator and do that by the numerator in the denominator. And I'm going to work my way across instead of down. Just keep in mind that I'm hoping this is my answer. Hoping I can get there. All right, now because I have that square root, I'm going to choose not to FOIL the numerator because notice it's the same thing. I could write it as 1 minus cosine x squared, and I know a squared and a square root can cancel out. That's why I'm thinking leaving it that way is going to be a wise choice. Now in the denominator, because of the difference of squares, I get 1 minus cosine squared x. And let me move over here and make sure I have room for everything. Oops, here the squared is on the outside of the 1 minus cosine. And because the squared is on the inside there in the denominator, 1 minus cosine squared is sine squared. Pythagorean identity. All right, so far I've just ignored the square root, so I didn't let it freak me out. But now that I have everything kind of simplified into a numerator and the denominator that both have a squared, and you wouldn't have to write this step, I'm just making sure you see it, you can break apart this numerator and denominator and take the square root of each. So the squareds cancel. I have 1 minus cosine x over sine of x. All right, so that's basically the answer. So now you're maybe like, okay, but we got that weird absolute value there. The only reason that is there is because technically sine can be a positive or negative number, right? Depending what quadrant it's in. But we could have only taken the square root of it if it were positive. So putting the absolute value there is saying, oh, the original sign had to be positive. It couldn't have been negative in this workout. Otherwise, we would have imaginary, and we're not going there. We're not going to imaginary sines and cosines. So there's our answer. All right. Now for the calculator piece. We've used the calculator with Trig on several different occasions at this point. In today's instance, we're going to use the calculator to verify whether or not these are identities. So are these things in fact equal? Because I don't want to waste my time doing all this work over here if I could never get it equal to the other side, right? The calculator can at least tell if it's possible. All right, well, how is it going to do that? Well, I know that I can take this side of the equation and put it into y1, and this side of the equation and put that into y2. If they are in fact equal, you should get the same graph. Right? Shouldn't they look the same if one side is equal to the other? If they're not equal, you'll get a different graph. Then you don't waste your time. All right, so let's enter this into the calculator. Tangent of x. I don't know if all the calculators are like this. Some of the newer versions might let you put the power like in the right spot. My version and older versions don't. So note that the fourth power is going to look weird, right? Just like the tangent squared. It looks like it's in the wrong place. Well, because it is technically. That's just how the calculator fixes it. I bet they fixed that on some of the newer ones. All right, now for secant, that's 1 over cosine of x squared. And then in parentheses, I have 4 tangent x squared minus 3. I'll close my parenthesis. All right, so you got to take the time, make sure you get it entered correctly. It doesn't matter a ton what our viewing window is. At least I don't think it should matter. I don't know what my window currently is, so I'm going to do zoom trig to just get a basic window. So zoom 7. All right, so it's graphing my first one. The color is nice here because I'm going to be able to see when they start graphing something else, but you can usually tell on your own as well. All right, now they're really close, but I'm just telling you, if they were the same, you would not be able to see the difference at all. They're close. If you're not sure, if you're thinking that those are the same, you could go to the table and see if you're getting the exact same answer. See how those answers are just a little different? They're not exactly the same. They're really close oftentimes. Sometimes they're not even close. All right, so look at the table, which is above graph, or maybe zoom in and out to get a better perspective. But it turned out that these aren't exactly equal. So am I going to verify this? I'm just going to say no, not equal. All right, let's look at the one on the right side. I think this will maybe help confirm my statement that those two weren't equal. Maybe I should have switched the order here. All right, let's enter this sine of x to the fourth minus 2 sine of x squared. Oh, I needed parentheses around that, and I forgot. If you ever do that and you didn't know how to fix this, you can go back to the beginning, arrow over. My calculator is bad at that. I arrowed over too far. And you can insert. Insert is above delete, so second delete, insert, and then you can put your parenthesis. If you didn't know you could do that. Now, annoyingly, I have to go back to the end again and enter cosine of x. All right, the other side is nicer in that it's just cosine to the fifth. That's not going to take me forever to type. All right, I don't need to do my window again. I've already done that once. I'm going to take a look at the graph. And that's a fun looking graph in my opinion. I like it. Oh, whoa. I have something wrong. This is not as planned. I meant for this one to be the same. Have I typed something wrong? Those are clearly not the same, right? Sine to the fourth minus 2 sine squared. Oh, there's a +1. I got so distracted by my parentheses that I left off the +1. But that was such a fun looking graph. I wonder if when I fix it, it'll just be as fun. So I get to do my second insert again. All right. And now graph it. I don't know, that one's maybe even better. Right? I don't know if you remember what the first one looked like now, but see how the red completely covered the blue? Before you could tell there were two colors still. Now one color has become the other. So these two are in fact equal. All right, so yes, they're equal. If they're equal, then yeah, you might as well go to the effort and try to verify it. If I was going to work with this, I would start over here, right? Because clearly this is the simpler version, the simpler form. And I see a trinomial. If you're still struggling with that, I know sometimes that's the case, right? You can think about your algebra. What would the factors be? Well, the factors would be x squared minus 1, and you'd have two of them, quantity squared. But it's not x, it's really sine. Sine squared x minus 1 squared. Oh, I still have the cosine x on the other side. All right, well now here on the inside, that's a Pythagorean identity. Sine squared minus 1 is, oh, negative cosine, right? Yeah, negative cosine squared. Doubted myself for a second. Squaring a negative, though, makes it positive. Two negatives become a positive, and cosine to the squared makes it cosine to the fourth. And now I have all 5 cosines, and we've verified it. All right, so you'll still be verifying. Towards the end of the assignment, you will be using your calculator to make sure it does work first. So good luck with that.